How we doing, guys? We're looking at page 147. We're looking at depreciation. We're going to start there with question 2. Question 2 there says a new television costs €1,400. Assume a depreciation rate of 8% per month. Find the value of the television after 15 months. Now, you could find 8% of 1,400, take that away, and then find 8% of the answer and take that away and do that 15 times. But of course, that would take a very long time. So an easier way to do it is to reduce something by 8%. You say, well, if I take 8% away, I'm left with 92%, so 0.92. Or you'll sometimes see that written as 1 minus r, so it'd be 1 minus 0.08 to take 8% away. So that's reducing it by 8%, and if you do that 15 times, well, you multiply by 0.92 15 times, or you raise that to the power of 15. So that's our depreciation formula, which is where we're starting. Sorry, my calculator over here. So the answer there, the question 2, is just going to be 1400 times 0.92 to the power of 15. Okay, so €400. After 15 months, this is going to have a value of €400 and 82 cents. So that's depreciation, and that's how we tend to look at it. It's called reducing balance depreciation. The other way you might see it is straight line depreciation, where you'd say, well, 8% of 1,400, 8% of 1,400 there is €112. So €112, you could say take that away every month. So you start off with 1,400, take away 112. So after 1 month, the price is 1,288. Take away 112 again. That's after 2 months, 3 months, 4 months, 5 months, 6 months, 7 months, 8 months, 9, 10, 11, 12. And here's the problem, is that after 13 months, your television now has a negative price. And after 14 months, it's an even bigger negative price. And we just know that's not how the price of televisions would decrease. So straight line depreciation we occasionally use as a very kind of rough model, but really we don't tend to use it at all. Question 4, a company buys a machine costing €140,000. In order to facilitate its repayment, they invest $25,000 in a bank, offering a return of 3.5% per annum compound interest. The machine depreciates at a rate of 20% per annum per year. Find the value of the machine in 4 years' time. Okay, so the machine was 140,000. It's depreciating at 20%, which means you multiply by 0.8 or 1 minus 0.2 to decrease by 20%. And you want to do that 4 times because it's over 4 years. So the price of the machine in 4 years' time is 140,000 times 0.8 to the power of 4. That's going to be €57,344. Okay, meanwhile, they've put this €25,000 into the bank, and part 2 of the question says find the value of their savings investment in 4 years' time. Well, that's earning 3.5%, so you increase it by 3.5%, so you multiply by 1.035. Okay, that's our future value formula. To the power of 4, because it's the same 4 years, isn't it? So 25,000 multiplied by 1.035 to the power of 4 gives us €28,688 and 8 cents if you want to include that. Part B says if inflation over the 4 years is at 2%, find the cost of buying a new machine in 4 years' time. So inflation is the rate at which goods increase generally in an economy. So the price of this machine is going to go up by 2% every year. So you start off with the machine costing 140,000, but in 4 years' time, you're going to say, well, I have to multiply that by 1.02, increase it by 2%, and do that 4 times over 4 years. The new price of the machine is going to be 140,000 multiplied by 1.02 to the power of 4. So that's going to be 151,000 €540 and 50 cents. And the last part says, how much money will the company need to add to their savings to replace the machine, taking the second-hand value of the machine in 4 years' time into account? Well, they need to have this much money, and they currently have this much. So the answer there is 151,540.5. Take away those two added together, which is 57,344 plus 28,688.08. We'll include the euros. So 151, oh yeah, that's there. Take away bracket 57344 plus 28688.08. Oh, I left out my brackets. I don't think that matters. Actually, that's fine. They'll still need another 65,508 euros and 42 cents. Excuse me. Question 7 then uses the same formula. It says a farmer buys a tractor for 180,000 euros. He assumes that it will have a trade-in value of 80,000 in 10 years' time. So what rate of depreciation is he working with based on these figures? Well, based on that figure, you're saying 1 minus the rate of depreciation, 180,000, multiplied by whatever you're reducing by, or 1 minus the rate you're reducing by. And that is in 10 years' time. So that's to the power of 10 is going to be 80,000. So this is going to be a logs question, I think. Oh, no, not even a logs question. 1 minus r to the power of 10 is 80,000 over 180,000. So they cancel. 8 over 18 is 4 over 9. Or you can work with a decimal, whichever you prefer. But if it's to the power of 10 on the left, that's going to be the 10th root on the right. Okay, so that's going to be 4 over 9 to the power of 1 over 10. Well, 4 over 9 to the power of 1 over 10. Now, let me just make sure that that is taking that whole fraction into account there. Just put a bracket around there to be sure. Gives us 0.9221. Okay, we'll work to 4 significant figures. 9221, 1 minus r. So 1 minus 0.9221 is equal to r. So our depreciation rate there is 1 minus this answer, 0.778. 89. And they're asked for it to correct to one place of decimals, which is 0.8. Oh, excuse me, there should have been a 0 in there. So, sorry, let's have a look at that again. 0.07, and you're going to change that to a 9. Now to one place of decimals as a percentage, so that's 7.9% depreciation is what they're working with there. And the next part of that then says, when will the value of the tractor fall below 60,000? Well, that is 180,000 euros times 1 minus 0.079 to the power of some unknown time needs to equal 60,000. Okay, so that is going to be 1 minus 0.79 is this figure we had here, 0.9221 to the power of n equals 60 divided by 180 is 1/3. Okay, and this is where we say, well, the one I always say, log base 2 of 8 is 3 is the same relationship as 2 cubed equals 8. So we want to get the 3 by itself, don't we? So 2 is in this place here, and 8 is in this place here. So we're going to say n equals, n is in the place where 3 is, log base 0.9221 of 1/3. Log base 0.9221 of 1/3 is 13 years, 13.546, and that's years. And the question says, when will the value of the tractor be below 60,000? Well, at 13 years it won't be below, at 14 years it will. Now, I wanted to look at question 10 as well, but I'm not going to write it out. Just they're comparing straight line depreciation here in red to reducing balance depreciation in blue for an air conditioning system that starts off with 80,000 euros. Using the graph, estimate the rate of depreciation. Let the value after 20 years be €1. Okay, so what they want us to do there, sorry I was wrong, I am going to write this out. Question 10, part 1. Well, we know that you've got this figure at 0, it has a value of 8,000, and we're saying after 20 it has a value of €1. Okay, so estimate the rate of depreciation. Well, we're going to say 8,000 times 1 minus the rate to the power of 20 equals 1. Okay, so 1 minus r to the power of 20 is 1 over 8,000. 1 minus r is 1 over 8,000 to the power of 1/20th. So 1 minus r, is 1 over 8,000, put that in brackets, to the power of 1 over 20. And what do you get there? You get 0.638. That's 1 minus r, so 1 minus 0.638 is the rate of depreciation. 1 minus that. So that's a 36.2% rate. Or, well, 0.3619, which I've rounded to 362, 36.2%. Explain why the reducing balance curve can never have a zero value. So saying that out loud, exponential curves, which is what that is, can never have a zero value, because no number, this number here is what's going to go in there, right? 0.638. You can't raise that to any power. There's no power big enough that will make it actually equal 0. Okay, it'll tend towards 0 but never equal 0. Find the slope of the straight line representing depreciation. Well, the slope is rise over run, so the rise is 8,000 over a run of 5. So 8,000 divided by 5 is 1,600 euros per year. Okay, estimate the point of intersection of the two graphs. It looks like it's about 4.2 years. After 4.2 years, they both agree on the price. Where it looks like it's about 1,500 euros, or maybe a little bit shy. In your opinion, which method of depreciation gives a more realistic value for the system? Obviously the fixed rate depreciation. The straight line depreciation after 5 years suggests your air conditioner has 0 value, which is probably not the case. And after 6 years would have a negative value, which is certainly not the case. Okay, I'm going to leave it there, and I'll ask you 2 other questions in the email. Bye bye.